Hi guys, in this video I will go over the nomenclature of acid derivatives. Carboxylic acid derivatives. First page here shows a number of carboxylic acid derivatives. Let's start there. Number of drugs here. The first drug, well, we can have a carboxylic acid here in Zyrtec, as well as in Allegra, 2 antihistamines, carboxylic acid groups here. But as we'll see, we also have derivatives of carboxylic acids, and those include esters, and we see an ester here, a methyl ester here in Plavix. We have an ethyl ester here in Flonase. And so, of course, recall that the ester is where the OH of the carboxylic acid is, where the H is replaced with an R group, in this case methyl or ethyl. So this is considered a derivative of a carboxylic acid. Flonase also contains a thioester, in which one of the oxygens has been replaced with a sulfur, and then the sulfur has an R group. This carbon group happens to have a fluorine bonded to it, but the group there is called a thioester. Now that's much less common than a regular ester, but I do point it out here since it's in this particular drug. Now, what is a carboxylic acid derivative? Ester, these two are derivatives. Note that we have a ketone here, okay? Ketone. The ketone is not a carboxylic acid derivative. How do you tell the difference? Well, all acid derivatives, or carboxylic acid derivatives, is going to have, or has, the carbon has 3 bonds to a more electronegative atom. And these are going to be carboxylic acid derivatives. The carbon of the carboxyl group has 3 bonds to oxygen. 3 bonds to oxygen. The carbon of an ester also has 3 bonds to oxygen. The carbon of a thioester has 3 bonds to a more electronegative atom, 1 to sulfur, 2 to oxygen. The ketone carbon does not. The ketone carbon only has 2 bonds to a more electronegative atom. So it's not an acid derivative. Neither is an aldehyde, if we see an aldehyde. That is, the ketone is at a different oxidation level than an acid derivative. And to go from an acid derivative to a ketone, you're going to need redox chemistry. Actually, a reduction. And it's often pretty easily recognizable when you have redox chemistry going on. Okay, so an acid derivative has 3 bonds to a more electronegative atom. The carbon does, of the functional group. Okay, other acid derivatives include amides. So we had esters, amides, sometimes called amides, sometimes called amides. I say amide. If you remember from Organic 1, amides can be classified as primary, secondary, or tertiary. This particular one is tertiary because the nitrogen is bonded to 3 different carbons, or to 3 carbons total. But you see that the amide is at the same oxidation level as the carboxylic acid because the carbon of the functional group has 3 bonds to a more electronegative atom. So that's Ambien. Lipitor, very important drug to treat high cholesterol, has an amide functional group and a carboxylic acid. Of course, it also has a couple of hydroxyl groups or alcohol groups, but those are not carboxylic acid derivatives. And certainly this carbon is not at the same oxidation level as this one because this carbon only has 1 bond to a more electronegative atom. We also have 4 different aromatic rings, 3 benzene rings, and then the aromatic pyrrole ring there in Lipitor. Okay, so acids, esters, amides, also nitriles or cyano groups. This is an acid derivative. Of course, that's a triple bond to N, C triple bond N with a lone pair. Okay, often just shown as CN. Need to know structure, of course, but the carbon has 3 bonds to a more electronegative atom. Now, all the above carboxylic acid derivatives have a carbonyl. Amide carbonyl, ester carbonyl. Of course, carboxylic acid has a carbonyl. The cyano group, of course, does not have a carbonyl, but it's still a carboxylic acid derivative. And we can convert from an acid to a nitrile without having to do redox chemistry. Okay, we'll be looking at these derivatives more and more as we move along through this material. Let's take a look at nomenclature. Nomenclature of acid derivatives. Let's start with carboxylic acids. These, of course, contain the carboxyl group. Okay, carboxyl group. Can be shown like that. We can show this condensed. It can be shown as CO2H. That's very common. Over here it was all drawn out. Very often you may just see sort of condensed drawn. This may also be shown as COOH. That is showing 2 oxygens separately. Okay. So how do we name carboxylic acids? Let's start with a simple carboxylic acid. Very similar to all of our other nomenclature. We have longest continuous chain. Okay. But the carboxyl group is the 1 position. A terminal functional group. That is, the carboxyl group carbon is always the 1 position. All right, so you might as well start there. Longest continuous chain, 1, 2, 3, 4. There's no other chain. That would be butane. But since it contains a carboxylic acid, we replace the E of butane with oic acid. 2 words. And this compound becomes known as butanoic acid, with numbering as shown. Pretty straightforward. Let's try another one here. Longest continuous chain. Well, this is always the 1 position. It's 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. Well, it's 6 right through here, yeah? I could have included the OH in the carboxyl. 1, 2, 3, 4, 5, 6. So that is not hexane, but hexanoic acid. What's on our hexanoic acid? At the 2 position we have a propyl. 2 propyl hexanoic acid. That's all one word. No hyphen between the propyl and the hexanoic. All right. What about this guy here? Well, the common name is acetic acid. You need to know that. You should have learned acetic acid in Gen Chem. You certainly learned the anion. The anion of acetic acid is acetate. A more general term for that is if you have the anion, just make it general there with an R group, this would be called a not a carboxyl, but a carboxylate. Or we can lengthen that out to carboxylate anion. Of course, it's an anion, but often just called a carboxylate. This is just a specific carboxylate known as acetate. What if we named this by more standardized IUPAC? Acetic acid is sort of a common name. IUPAC would be 1, 2. It would be ethane. We replace the E with oic, and then say acid. Ethanoic acid. But nobody calls that ethanoic acid. Everybody calls that acetic acid. Another one, what about this carboxylic acid? It's the smallest carboxylic acid you can have, with just being H coming off that carbon. It is possible. That's called formic acid. Common name. If we were doing IUPAC, this would be just one carbon. It would be methanoic acid. But nobody calls it methanoic acid. Nobody calls it ethanoic acid. It's called formic acid. This name comes from the fact that this compound is found in ants. And scientific name for ants is it Formica? Formica sounds like a countertop. What's the scientific name for the common ant? According to Uncle Wikipedia, it's Formicidia. However you pronounce that. That's the family that ants belong to. You may have heard that in biology. I had to look it up. But ants contain a good bit of formic acid. And if an ant bites you, it injects formic acid into you, and that's going to cause an allergic reaction and a little bit of pain there with that acid. from the ant bites. And by the way, you can take, if you take like lots of ants and put them in your round bottom flask, you know, like thousands of ants, and shove them in there and then heat it up, and you can actually distill formic acid out of that, and it will distill over, and you'll leave behind just dried up ant carcasses. That's been done before. But that's where that common name comes from. Okay, let's look at here, this compound. GHB. Let's name this compound 1, 2, 3, 4. Butanoic acid. But it's got a 4 at the 4 position. There's a hydroxy. 4-hydroxy butanoic acid. Okay, hydroxybutanoic acid. What's the G? The G is because another way to kind of number this is alpha, beta, and gamma. That's also called the gamma position. And you could also call this gamma hydroxybutanoic acid, GHB. You may have heard of GHB. It's so-called date rape drug. It's a hypnotic, and used for sort of nefarious purposes there, to sort of sedate someone unknowingly by adding it to their drink or something. But that's where the name GHB comes from, gamma hydroxybutanoic acid. Okay, one other thing to add here is, remember your amino acids? Proton building blocks, which you've probably learned in biology at some point. You'll certainly see those in biochemistry. But those are alpha amino acids. The first carbon coming off the carboxyl is the alpha. That's where the amine is. Alpha amino carboxylic acids. These are your building blocks for your proteins, with just the R group here, also on the alpha position, varying. If R group is an H there, that would be glycine, which is the most simple amino acid. Okay. There should be nomenclature in your textbook for practicing more with carboxylic acids. Okay, let's look at esters. Esters, we sort of named the carbonyl portion as an O8. That's really not right here. Really this should be, the oxygen is included there. Yeah. If we just have the oxygen, remember it's a lot like carboxylate. And so what we have here is boom, boom, boom. That there, and it's usually a minus if it's by itself. And then what is on that? Well, this is a butanoate. But if we put an R group here, like an ethyl, this becomes ethyl butanoate. And so this is the R group that's on the ester. Let's do an example here. Let's name the carboxylate. That would be this here. Longest continuous chain, 1, 2, 3. Either way you go is 4. So it's a butanoate. 1, 2, 3, 4. What's on the butanoate? A 3-methyl. Then what is the R group which makes this an ester? With your R groups, the first carbon is number 1, always, coming off the oxygen. So this is 1, 2. It's an ethyl, but it's got a fluorine on it. The fluorine's at the 2 position. So it would be a 2-fluoroethyl. Three-methyl butanoate. All right. This is 2 words. Esters are named with 2 words. I'll let you try this one on your own. All right. What are some common esters? Well, one is ethyl acetate, a very common solvent in the lab. If we just take off the ethyl, that's acetate. Of course, it would be an anion. But if we add an ethyl to that, it becomes ethyl acetate. Okay? Very common solvent in the lab. And the acetate, of course, is a common name. Now, of course, the O-ethyl bond here is covalent, where if we had just an anion and a sodium, this would be ionic, and such as like sodium acetate. Of course, anytime you have an acetate, you got to have a positive, and that would be an ionic bond there, ionic attraction. I reckon I'm showing this because just because I did not show the charges here doesn't mean this is not ionic. Just like if I showed sodium chloride, this is really 2 ions, right? Well, that's really 2 ions. But up here, this is not ions. This is all covalent. O-carbon covalent bond. Okay, let's look at amides. Long name for an amide is carboxamide because it has the carbonyl. Okay. But usually we just say, we shorten that to amide or amide. Very difficult here, guys. We replace the E, longest continuous chain, 1, 2, 3, 4. Instead of a butane, we see that it's an amide. We replace the E with amide. And the name becomes butanamide. So this is butanamide. And for example, if we had a chlorine on this carbon, it would be 3-chlorobutanamide. Now with amides, we can put R groups on the nitrogen and it remains an amide. Of course, up here, if we put an R group on the oxygen, it goes from a carboxylic acid to an ester. But not with amides. So this is still an amide. This would be called N-methylbutanamide. We often use, if the substituent is on the nitrogen, we use N, a capital N. Instead of a number. If we said 2-methylbutanamide, that would be this with a methyl at the 2 position. But this is N-methylbutanamide. Okay, let's try this one here. Actually, why don't you try this on your own? Longest continuous chain, pretty straightforward. It's a benzene ring. We got to remember, what do we call a benzene ring when it's part of nomenclature? It's a substituent on the nitrogen. Couple of common amides. Well, actually, the first one is not that common. This one here I'm illustrating, what if we have two methyls on the nitrogen? We would call that NN-dimethylbutanamide. Now, if the groups were different, maybe if one's methyl, one ethyl, you would say something like N-ethyl N-methylbutanamide. A common amide, a common solvent, is DMF. Fairly common in the lab. DMF stands for NN-dimethylformamide. Got to keep in mind that this is formic acid. And so the formamide is a common name which comes from formic acid. And I'll rewrite this. If we had just NH2, this is called formamide. But this is called NN-dimethylformamide, or DMF, a common aprotic solvent, where formamide would be a protic solvent, although actually I think formamide is a solid. I'm not sure. Maybe a solid, and if it's a solid, you're gonna have a tough time using it as a solvent. But DMF is a liquid. We've removed hydrogen bonding potential between molecules because all we have left is a hydrogen bond or hydrogen bond acceptors. There's no longer any donors. And indeed, DMF is a liquid. It's a common polar aprotic. Let's write that here. It's polar. It's got a carbonyl. Okay. One other one. We're not going to look at the nomenclature of nitriles, but I do want to point out one common nitrile solvent, acetonitrile, which we actually do use in the Organic 2 laboratory. Methyl with a cyano group. Sometimes people call this methyl cyanide, but I do not like that name at all. You should call this acetonitrile. Again, the aceto, that's because CH3, it's acetic acid. It's the nitrile of acetic acid. It's where the carbon has been converted to a nitrile, and we use the aceto. You see that a good bit. It's the functional group with a methyl. Functional group with a methyl. If we had the functional group with an amide, this is called acetamide. Some people may say acetamide, but acetamide. So this acetyl, and by the way, we'll see this later, just a carbonyl with a methyl is known as an acetyl group. We'll see that in particular during test 4 when we do aldehyde and ketone nomenclature. But we're kind of seeing that here. It's sort of the amide of acetyl amide. It's called acetamide, or it's the acetyl acid. It's called acetic acid. Okay, so there's some common names here. I point this out because you see these a good bit in lab. Then we also have our more standardized IUPAC, and you can do this one and this one for practice, and we'll do those in class at some point. Okay. Now, one other thing I wanted to add with the nomenclature is with carboxylic acids, so-called fatty acids. You see these a good bit. Lipid or fats. These can have a saturated side chain, that would be called a saturated fat, or these would be sort of called, this is a polyunsaturated fatty acid. I showed one handout of these in Organic 1 when we were looking at alkenes and the difference in melting points of some of these. Wanted to point out this sort of fairly common nomenclature of using omega. Alpha linoleic acid is known as an omega-3 fatty acid. Omega is the end. What this means is the third carbon from the end is where the first alkene is. 1, 2, 3. First alkene is 3 from the end. Sometimes I may have mispronounced these. This is linolenic acid. This is linoleic acid. Very similar, but it's an omega-6 fatty acid because the first alkene does not occur until 6 in from the end. And oleic acid is an omega-9 fatty acid. And you see these sort of omega fatty acid supplements. This one here has all 3 common types of the fatty acids, that is omega-3, omega-6, and omega-9. So it's a mixture of various fatty acids. So you've probably heard of that terminology. I just wanted to point that out. So it would sort of make sense to you, and hopefully it does. Okay. What's this? Trip of a century. Ever heard of LSD? Here's LSD. What type of functional groups do we see here? I see a tertiary amide. Of course, an amide is a carboxylic acid group. We also see a tertiary amine. We also see this sort of isolated alkene. We also see, this is a tryptophan ring. But I just wanted to point out just another interesting carboxylic acid derivative. Tertiary amide in this case. You can read here about how LSD was discovered sort of accidentally. Back in the 1940s. Beautiful molecule. Okay, guys. Oh yeah, one last thing I wanted to show you, meant to mention over here, is butanoic acid. That name, where did some of these prefixes come from? The but here came from butter. Butter has a large amount of butanoic acid in it. And I could be wrong, but I think the bute sort of came about because they knew that butter contained a lot of this particular compound, and they eventually knew that it was a 4-carbon carboxylic acid. And I think that's how the 4-carbon fragment became known as butyl. So, just a little interesting tidbit there. Okay, guys. We'll look at the rest of this handout in class. Please be looking ahead at that. We'll be looking at the acidity of carboxylic acids, but also phenols. We're going to do a little review of our acidity and how functional groups can affect the acidity. While we're at it, we'll look at basicity of anilines, because the discussion goes with the discussion of the carboxylic acids. So some acid-base chemistry here. A lot of it sort of be kind of review, pulling that together. We'll also look at review our extraction process that we can use to separate such compounds. By the way, here's the carboxyl group shown sort of condensed with the COOH. Yeah. Like we mentioned, that we may see. Okay, and a couple of other miscellaneous things here, including some fragrant esters here. And by the way, you might try to name some of these. Well, they've already been named for you. You might check these names. Does this name sound right for this compound? And so you might check your nomenclature here. Maybe try to name these and then check the answer. Now, some of these may be common names. This acid we actually have seen before, I believe. Yeah. Aromatic nomenclature. A quick look. It looks like you should be able to name really all of these. So that would be good practice to name these esters. And then you can also see what fragrance they have. Esters are often quite nice smelling. I want to say aromatic, but aromatic means something different to us. They often have sort of interesting smells, either fruity or other pleasing smells. And a lot of times ester compounds are included in perfumes. Okay, guys, that's nomenclature of acid derivatives. See you soon, guys.